the position vector of a particle is r equals to 4t minus 1I plus d squared j in meters at time t seconds. What is the velocity of the particle v in terms of t? You know the formula to calculate the velocity vector of a particle when the displacement vector or the position vector is given is dr dt. That is, I differentiate the position vector with respect to time. From the equation, the position vector is this. That is, the position vector is equals to 4t minus 1I plus t squared j. These I and j are unit vectors. That is, unit vectors in the x and the y axis respectively. That is, in the x-axis we always have the unit vector I, in the y-axis we have the unit vector j. So it means this particle have two dimensions, that is the x component and the y component. So this is the x component and this is the y component. You know that if r is equals to xi plus yj, that is the x and the y component, then the velocity will be equals to dr dt according to this formula, which is the same like differentiating this position vector or displacement vector component by component. That is, we differentiate the x component with respect to time I plus the differentiation of the y component with respect to time then j. So that is the same thing I am going to do here. That is, dr dt, which is the velocity, is equals to the differentiation of r component by component. That is the differentiation of the x component, which is 4t minus 1 with respect to time I, unit vector I, plus the differentiation of the y component, which is t squared with respect to time, unit vector j. To differentiate this, I'm going to use the differentiation formula. You know, if y equals to x to the n, it means dy dx is equals to the same like vx to the n dx, which is equals to nx n minus 1. That is the same thing I'm going to do here. To differentiate this one, I need to also separate into terms. This is a term, this is another term. You know, a term is always separated by a negative or a positive sign. Now, I'm going to have the differentiation of 4t with respect to time minus the differentiation of 1 with respect to time, all into unit vector I, plus the differentiation of t squared with respect to time times unit vector j. You see, using this formula, the differentiation of 4t is 4. The differentiation of any constant is always 0, so it means that here I'll have minus 0. All this times unit vector I. Now, the differentiation of t squared according to this formula is plus 2t. You know, the differentiation of t squared according to this formula is the same like taking 2 minus 1 times 2, where n here is 2 according to this formula, which is the same like 2 times t to the 1 power. You know, 2t to the first power is the same like 2t. So that is why I am having 2t here. Now, I need to simplify this. Here is 2t times the unit vector j. You know, the position vector was a vector, so you keep on maintaining the I and the j, since velocity is also a vector. So here I will have 4 minus 0 is 4. That's 4i plus 2tj. That means the velocity v is equals to 4i plus 2tj, all into meters per second. So this is the velocity of the particle required in terms of t.